Hello students, we will be solving question number 5 from the exercise 2.3 chapter polynomial. So our question is, give examples of polynomials p of x, g of x, q of x and r of x which satisfy the division algorithm, and degree of p of x is equal to degree of q of x, degree of q of x is equal to degree of r of x, degree of r of x is equal to 0. So our question they want is, they have given us some conditions where the degrees of p of x, that is your dividend, should be equal to the degree of quotient. So such condition is to be satisfied along with the condition that division algorithm should be maintained. Okay, so let's see the examples for the first one, where you have degree of p of x is equal to degree of q of x. This you need to prove it equal. So if you want degree of your quotient to be equal to the degree of the dividend, your divisor should be a constant number. Okay, so select p of x in such a way. Suppose in this example we have selected this p of x 2x square minus 2x plus 14, which is a multiple of 2. See, this is 2x square, this is 2x and this is 14. All the numbers can be divided by 2. So that is why we have taken g of x as 2, which is a constant number. So if the requirement is that the degree of quotient and degree of my dividend should be same, the degree will be same only when your g of x, which is divisor, is constant number. Okay, so when we divide this p of x upon g of x, so what you get, you take 2 common outside, 2 and 2 will get cancelled, and you get quotient x square minus x plus 7, and since it is completely cancelled, there is no remainder here. Okay, so that is why you have x square minus x plus 7 as the quotient and remainder as 0. So your q of x is x square minus x plus 7 and your r of x, which is remainder, is 0. Now we can verify this division algorithm. If you multiply this, that is g of x, which is your divisor, that is 2, your q of x, which is the quotient, r square x square minus x plus 7, and your remainder 0. So you will get 2 into this, which is again your p of x. So hence the division algorithm is satisfied. Okay, this is how you select a random polynomial. Okay, but you have to remember, if your degree of the quotient and degree of the dividend is supposed to be same, so in that case your g of x, which is divisor, should be a constant number. Okay, and second question, they require degree of q of x should be equal to degree of r of x. So that means degree of the quotient should be equal to the degree of remainder. For that, I take p of x as this polynomial, which is 4x square plus 4x plus 4, and g of x is, if you take this constant term outside, okay, just the inner all algebraic terms, which is x square plus x plus 1, if I take 4 common. Okay, so that I can have quotient as a constant number. Okay, so when you divide this 4x square plus 4x plus 4, so you get quotient as 4, and after division the remainder is 0. Now what we wanted, degree of the quotient and degree of remainder to be same. So here degree of quotient, my quotient is a constant number, and since it completely divides, so my remainder is also 0. Hence the degree of this quotient, there is no x term, so degree of this quotient is 0, and remainder is 0, therefore degree of this remainder is also 0. Now the degree of quotient and degree of remainder is same. So how to select this polynomial? Select a polynomial which is completely divided by the other polynomial. So in this case I have taken which is the multiple of a number. So you can select a polynomial such that it is multiple of some number. Okay, and this is how it can be done. So this also verifies your division algorithm if you substitute the value of p of x, g of x, q of x and r of x. So if you multiply this 4 into this, you will get p of x, which is completely true, and your remainder is 0. Okay, and third question is degree of r of x is equal to 0. Degree of r of x will be 0. So last question that we have solved here, the degree of rx is 0. You can take down the same example, or we have solved question number 4. There you had this question where the remainder was 0 again. If we can see that sum, it is x minus 2 and x cube minus 3x square plus 3x minus 2. This can be again your example where it completely divides, it is divided by x minus 2 and you get remainder as 0. So this is your, again you have an example where the remainder is 0, hence the degree of the remainder is also 0 and it satisfies the division algorithm.